Hi, this is Sarah Parker, and I'm going to be doing some code walkthroughs for CPSC 5010. This is for Assignment 3. We had 4 different programs to write again. The first one is 3.1, and it asked us to write a program that would read in 10 numbers that the user would input and then display only the distinct numbers. So if 1, 2, 2, 3, 4, so on was put in, it would only display the 2 one time. So the first thing that we did is to include our IO stream, and we're using our namespace std just to make our code a little bit cleaner. In the main program, I just wrote this as a main program. I did not do it as a function this time. But we have an array declared that will hold 10 numbers of integers. And then we have a second array called distinct, which will also hold 10 integers. Our count is set to 0. We have 2 separate variables of integers, I and j, and then Boolean is distinct. So the first thing is that we're going to print to our terminal asking our user to input 10 numbers. After that, we used 2 loops, an outer loop and an inner loop. So our outer loop is going to assign the input from our user into our first array, the numbers array. So I is 0, less than 10, I plus plus. For every input, we're going to assign that to number at I, and then it will be is distinct true. Then we're going to do our inner loop to see if it actually is distinct. So we're going to go J0, J is less than our count, and right now our count is set for 0. If that is and then we'll increment that j++. If our number at I, so starting here, is equal to our number at j, then is distinct is false. So it would be the same number, so we don't do anything with it. However, if is distinct is true, so if it doesn't meet this requirement, then we're going to add it to our distinct number count. Distinct at count, so starting distinct at 0, is numbers at I, and then we're going to increment our count. So this way it's going to loop through, we're saving our numbers into array, looping through that array to identify the distinct numbers only and saving that into our second array. Then we're going to output only the distinct numbers by using a loop, and we're looping through our distinct numbers and our count. And the count is basically limiting how many numbers end up in our distinct array. So if we pull it up on PowerShell, just to maybe. Here we go. Okay, so if we pull up PowerShell, I will go ahead and run. I don't know if you guys can actually see that. Yeah, okay. So then we'll run our distinct numbers. And we'll enter 10 numbers. We'll make sure that we have some repeats. So we'll do, okay. And so here you can see that it output our distinct numbers. Because we had 2 1s, it only put out 1. We had 2 2s, it only put out 1 2, 3, 4, 5, 9, and we had 2 8s, it only put out 1 8. So the program does run the way that we expect it to. We'll go ahead and minimize that and pull up our code again. There we go. Okay. So moving on, we are going to go to our second assignment, which was called single digits. This program generates 100 random numbers, all between 0 and 9, and then displays the count for each. So opposite to the last program where we only wanted our distinct numbers, now we want to know how many 1s were generated, how many 2s were generated, and how many 3s were generated, so forth between 0 and 9. So in our main program, we needed to include a few extra headers. So I actually don't need the time header. I was using that for a random one earlier, but anyway, we could actually eliminate this time one, but we do need our math header because we're going to be doing some functions in that math library. So in our main program, once again, we are initializing a array of integers, and they're called counts, 10 integers. This time we're initializing them all to 0. And then we also have a variable I and a variable number. Those are both integers as well. So first we want to generate our 100 random numbers between 0 and 9. So I starting at 0, I up to 99. And then our number is going to equal a random number modulo 10 to make sure that we get it between 0 and 9. And then at our counts, we are going to increment the number. So let's say if this number that was generated was 7, then counts at 7 would increment by 1. So at index 7, we'd increment that one time if 7 was the number that was generated. And that's how we're going to increase our counts. Every time a number is generated at that index, we increase the count. So then to display the counts, it's a pretty simple loop. The count for I is starting at 0, less than 10, so we're just going to loop 0 to 9, and then we're going to display what the number was at that index because we've incremented it every time. So we know how many ones we have, how many twos we have, and so forth. So let's pull up our PowerShell once again, and this time, what was that program name? This one was single digits. Okay, so we're going to run single digits. And you can see that the count for 0 was 7. The count for 1 is 14. So 14 ones were generated, 11 twos were generated, and so forth and so on. So this program did run the way that we expected it to. And for our third program, this one was called sort. So this one asked our users to enter the number of students, the students' names and their scores, and then print the student names in decreasing order of their scores. So the student that got the highest score would be printed first, and then it would decrease in order to the student that got the lowest score. Alrighty, so for this one, we used our typical headers, IOStream and string, and then we used namespace std. Again, that's just to make our code a little bit cleaner. So all this was run in the main function as well. You could write a function for it. So our variables are an integer, num students, a string that is actually a pointer to names, a integer that's a pointer for scores, and then 2 variables that are integers I and j, a string that is temporary name, and a string that is temporary score. And the reason that we have all that is because we're essentially going to store all of our student names in one array, all of their scores in a different area, and then we are going to check them to see whose is higher, whose is lower, swap them, and save them accordingly, and then move on. So the first thing that we're going to do is to ask our user to enter the number of students so that we know how big this is going to be. And then the second thing that we're going to do is save that into the variable number of students. We're going to create dynamic arrays for the names and the scores because initially we don't know how many students we have until the user puts that in. So names, again, up here, pointer, is going to be a new string of arrays, number of students. Scores is going to be a new integer array, number of students. So that way we have the right size array for names and the right size array for scores so that they match. And then we're going to ask our user to enter the student's name and the student's score. So that way they get saved in the appropriate slot so that at index 0 is Mary and index 0 score is Mary's score because we don't want to save her in a different spot. That would mess up our sorting ability. From there, we're going to sort it. This is where it gets a little fun. So we're going to loop through all of our students at first. So I0, I less than the number of students, minus 1, coming back 1, and then I++. So as we loop through it, then we've created an inner loop, and we're going to start that at the next index. So we're starting I at 0, we're starting J at 0 plus 1, and then we're going to loop through each one from there, comparing it to our I. So if the score at I is less than our score at J, so initially this would be our score at index 0. If that's less than our score at index J, which would be index 1, so 0 and 1, then our temporary name becomes our name at 0. So this is if the score is lower. Then our name at I is equal to our name at J, and the name at J is equal to the temporary name. So we're just moving them around depending on who has the higher score versus the lower score. And then we're moving their scores in the same order. We want their scores to stay with them. So we loop through all of that, and then we go through our outer loop again, and we start at index 1, and then we go through and make sure everything lines up. So then we're going to print everything out. We're going to print the students' names in decreasing order of their scores. So we're looping through our students, and then we're putting out their names. And then just to clean up some memory, we're deleting these dynamic arrays that we had created before. So to see this in action, let's just do 3 students to make it easy. So that'll create our dynamic array sizes of 3. We'll say Mary is our first student. She got a 92. Kim is our second student. She got an 88. And John is our third student, and he got a 99. So before I hit enter, what we should see is that John's name is printed first, Mary's name is printed second, and Kim's name is printed third. Let's see. John, Mary, and Kim, just like we wanted it to. So for our last program, this was actually a game that we were asked to create, a number guessing game. And then there were some modifications that we were instructed to do as well. So we included our IO stream, our standard library. We're using our namespace. This time I did use the C time because I wanted truly random numbers each time, so I seeded them. We have an int variable for number and an int variable for guess, and then an int number guesses, and that's set to 0. So for the first game, I did do functions for this game because of the modifications. That way, once we got to our main program, you could run each function depending on the modification that you wanted. So our first game is called Player Guess. So this is the computer is picking a number between 1 and 100, and it's our job to figure out what that number is. So we generated our random number using the sran time, which will seed us a random number every time, not the same random number every time. So that's why we use the sran. And then the computer will tell us they picked a number, and then we input our guess. And then this was the first modification, but I went ahead and just put it into the program. It asked us to keep track of the number of guesses so that you know how many times it took you to actually pick the correct number. So let's see, we used a while loop and then put an if else statement in there. So while that initial guess that we input does not equal the number, which was the number the computer generated, if the guess was less than the number, then the computer is going to tell us too low. Else, if the number is too high, try again. But if our guess is the number, then congratulations, we picked it in X amount of guesses. So, and that's basically going up to here. If wild guess does not equal the number. So if we guessed it the first time, the only thing that would happen is we would output the number, output the congratulations. The second part of the game, the second modification, is that the user picks a number and the computer guesses the number. So for this one, the user will pick a number, but just keep it in their head. They don't have to input it into the terminal or anything like that. We have variables for low of 1, high of 100, a character for response, and then a Boolean for correct, and then an integer for answer. So while not correct, we are going to randomly pick a number, and this is the computer's guess that they are picking. So the guess is going to equal a random number modulo high minus low plus 1 plus low. So that's basically just saying our high number was 100 minus our low number of 1, that's 99, plus 1 is 100, plus our low number 101. So we're moduloing it to make sure that we're between 1 and 100. A little complicated, but it works. Then we ask the user, think of a number, and then is the number, and the computer will put their guess in based off of what we just did for our random number. And then it's the user's response to either tell the computer it was too high, too low, or correct. And we're doing that through the characters H for high, L for low, C for correct. That's this character response variable up here, and that's what we're saving it in right here. So if the response is correct, okay, great. The computer guessed it straight away, and it took one guess. If it's too high, then the high number becomes the guess minus 1. And so that resets our random variables up here to only pick between 1 and then the number that they guessed, because we know it's not anything higher. It has to be lower. And then the opposite is true if it was too low. So then the low becomes that guess. That sets the new benchmark, and then we can go up to 100. We increment our number of guesses so we can keep track of that. So that is how the computer portion works. The third modification was the third modification was so that the computer could guess the number in 7 tries or less. And I did look this up. The way to do that is by using a binary search. And a binary search is going to essentially start in the middle of your numbers. So if we're 1 to 100, it's going to start at 50. And then from high or low, it goes from there. If 50 is too high, then it's going to split the middle between 1 and 50 and start at 25. And that's how you end up splitting the middle every time so that it's 7 guesses or less. So we have our low is 1, our high is 100, our character response, our Boolean, and then our number of guesses. So while not correct, so while the computer's guess is not correct and the number of guesses is less than 7 still, then our guess is going to equal the low plus the high minus low divided by 2. So we're not using random guesses anymore. We're literally just splitting the difference, starting at 50. And then the same kind of if-else statements are true. So if correct, congratulations. If it's too high, adjust the range, and then split the middle again, and that's the next guess. And if we have like a totally opposite, if we have an incorrect guess, then we let the user know that. So we will do the player guess first. So let me comment out the others. We'll save that. And then I'm going to need to compile it. Okay. So we've compiled it. Now we're going to run it. Oh, whoops. Try again. Now we're going to run it. Okay, so the computer picked a number between 1 and 100. We're going to guess 60. Too high, try again. Let's guess 30. Oh, wow. I've never guessed it in 2 guesses before. Good for us. Okay, so that's how the first modification works. So let's go back and we'll make the computer guess our number. We'll save it. Let's give ourselves a little bit more room. Compile it. Run it. Okay, think of a number between 1 and 100, and I will guess it. So let's say our number is 26. Is the number 63? That is too high. So we'll enter H for high. Is the number 27? Close, but that's still too high. Is the number 22? That's too low. Is the number 24? Too low. 25? Too low. 26? Correct. So the computer took 5 guesses to get that one. And that wasn't even our program that makes it do it in 7 guesses or less. So let's go back and we'll change our program one more time so that we can demonstrate the 7 guesses or less. And pull that up. Let's recompile it. And let's play. Okay, think of a number between 1 and 100. I'll guess it in less than 7 attempts. Is it 50? So that's what I was talking about. It's going to start at the middle, right at 50. We're going to say the number's 74. So that's too low. Is the number 75? That's too high. 62, that's too low. 68, that's too low. 71, that's too low. Now I'm forgetting what my number was. I think it was 74. Too low. 74, correct. So it took exactly 7 guesses, but the computer did get it in 7 guesses or less. So those are the programs for CPSC 5010 Assignment 3. That was Assignment 3.1 through 3.4. Thank you very much.